Chapter 5. Learn to program with Scratch. Central idea. What is Scratch? Scratch anatomy. Built-in image editor of Scratch. Foundations of programming and specific programming concepts. Renaming the sprite, adding backdrop, making the sprite move using go-to and glide blocks. What is Scratch? Scratch is a free programming environment that runs on the computer and can be shared with online community. It was designed by the lifelong kindergarten group at the MIT Media Labs. Scratch users call Scratchers, where they can create programs by snapping together the code blocks in the Scratch editor. Although Scratch was designed for 8 to 16-year-olds, Scratchers consist of people of all age groups. This software makes it easy for anyone to start developing their programming and problem-solving skills. Scratch anatomy. Scratch provides an integrated development environment, IDE, that enables us to design, program, and run our projects. You can see it in the following screenshot. Menu bar, tabs, project name, blocks area, script area, green flag and red stop flag, stage, sprite pane. Scratch is an event-oriented language where we use blocks to do things in response to an event. The stage area. The space on the right side of the window beneath the green flag and the stop sign is the stage area. This is an area where all the sprites works as per their scripts, and we can see the all results of our programming. We can add different backdrops on the stage. The sprites pane. Sprites are the characters or objects in the Scratch project. The list of sprites can be found below the stage. The most basic object in Scratch is the sprite. The editor automatically starts with a cat sprite for all new projects, but we can add new sprites on the stage. The scripts area. Script is a collection of programming blocks that should be added for each sprite to animate, move, or interact with other sprites on the stage. Script area is in the middle of the Scratch window where all the blocks of the script is added. If you click on a sprite, the project editor will show the existing stacks of blocks in the scripts area. Project name. The text field at the top of the editor contains the project name. After you've named your project using a descriptive name, remember to save your project by clicking File, Save Now from the menu bar to avoid losing your work. Blocks area. The coding blocks can be accessed from the blocks area on the left side of the window. There are 9 categories of code blocks: motion, looks, sound, events, control, sensing operators, variables, and my blocks. These are placed at the left side of the blocks area. Every coding block belongs to one category and is represented by the color of that category. For example, the Say block comes from the Looks category in blue color. An infinite supply of code blocks is available in Scratch. Just drag them from the blocks area to the scripts area for programming the sprite. Each of the sprite has its own scripts of programming blocks. When you click the sprite in the sprite list, that sprite's scripts will be displayed in the scripts area. If you want to draw a new sprite or change the look, costume, click on the costume button on the top of the scripts area as it is replaced by the paint editor. And if you want to change the sound effects of the sprite, click on the Sounds tab. The green flag available at the top of the stage is used to start the programming of the sprite. Red stop button will stop the program. The built-in image editor. One of the core features of Scratch is its built-in image editor, which allows us to draw our own backgrounds and sprites. Scratch helps to draw graphics, which allows you to create an image that are smooth and scalable to any size. The Paint editor allows you to perform the following tasks. It can create different shapes, backgrounds, and text. Camera option is used to click the picture and can be used as a background or a sprite. It can apply or change the color of the sprite. It can resize and change the orientation of any image or a sprite. To draw a new sprite, click the Paint button on the Choose a Sprite button. You can also change the looks of a sprite by switching to one of many costumes available in the Costumes section. To create a new sprite, perform the following steps. Step 1. Click the Paint button. The main parts of the Paint editor are Select tool. It looks like a mouse pointer on the Tools section. It is used to select or modify the sprite by resizing, stretching, rotating, or changing the location. The drawing tools can be selected using the buttons on the left side of the canvas. Brush tool is used to draw a freehand drawing on the canvas. We can change the color of the brush by Fill option available above the drawing tools. Fill tool is used to fill the colors in the drawing. Line tool is used to draw straight lines on the canvas. We can change the width of the line by changing the number from the width box available on the top of the tools. We can add outline also from Outline option. Rectangle tool is used to draw squares and rectangles on the canvas. We can change the size and color of the filled shapes. Reshape tool is used to reshape any object on the canvas. Eraser tool is used to erase anything on the canvas. We can change the size of an eraser by the size number appears on the top of the tool. Text tool is used to add the text as a sprite on the canvas. We can change the font of the text from the font list available on the top of the tool. Circle tool is used to make circle or ellipse on the canvas. Zoom buttons are used to zoom in or zoom out the canvas to give sharper details on our sprite. The Equal to button brings back to the original size of the canvas. The Undo or Redo button is used to correct the mistakes done while drawing an object on the canvas. The Costume Center indicates the center of the costume with the crosshairs symbol. The foundations of programming. Programming is writing the instructions to do a particular job. Instructions are by default obeyed one after another, and when the blocks are put together in a chain, they execute them one after the other. Sometime we need to select set of instructions with some conditions in it is known as conditional control. For example, if statement. Sometime we also need to repeat a set of instructions until some condition is satisfied is known as looping control. For example, loop statement. With these three controls, default, sequential, conditional and looping, any program can be written. Scratch has all these three forms of control. A sequential flow of control can be written just by putting blocks together. Specific programming concepts. Concept, explanation, example. Sequence. To create a program in Scratch, you need to think sequentially about the order of steps. Go to, Y, glide, Play sound, meow until done. Say, let the show begin for iteration, looping. Forever and repeat blocks can be used for iteration, repeating a series of instructions. Play sound, move 10 steps, turn 15 degrees. Conditional statements. If and if-else blocks. Check for a condition. Position 200. Variables. The variable blocks allows you to create variables and use them in a program. The variables can store numbers or strings. Scratch supports both global and object-specific variables. When clicked, set score to 0. Forever, move 10 steps. If touching color 9, then change score by 1. Lists, arrays. The list blocks allow for storing and accessing a list of numbers and strings. This kind of data structure can be considered as dynamic array. Pick 1, bread, 2, food, add red apples to food, set counter to 0. Repeat length of food. Say item counter of food, change counter by 1. Event handling. When key pressed and when sprite clicked are examples of event handling, responding to events triggered by the user or another part of the program. When space, key pressed, point in direction -90, move 10 steps. Threads, parallel execution. Launching 2 stacks at the same time creates 2 independent threads that execute in parallel. Coordination and synchronization. Broadcast and when I receive blocks can coordinate the actions of multiple sprites. Using broadcast and wait blocks allows synchronization. For example, sprite 1 sends the message winner when this condition is met. Wait until score greater than 100. Broadcast winner. In this script, sprite 2 is triggered when the message is received. Random numbers. The pick random block selects random integers within a given range. Set x to pick random 100 to 100. Boolean logic. And, or, not are examples of Boolean logic. Dynamic interaction. Mouse _x, mouse _y and loudness can be used as dynamic input for real-time interaction. Forever, set size to loudness 4%. Use interface design. You can design interactive user interface in Scratch, for example using clickable sprites to create buttons. The first game. Let's get to know Scratch. We'll also learn about sprites and coordinates. We need to get Scratchy the cat moving again. We'll make it dance across the stage. Renaming the sprite. Step 1. Type the name Scratchy in the text box. The name of the sprite 1 has changed to Scratchy. Adding the backdrop. In Scratch 3.0, the picture on the stage is called a backdrop. But in the previous versions of Scratch, the picture on the stage was called background. Step 1. Click on the Choose Backdrop from Library. A new window opens with different types of backdrops. You can click on any backdrop to add on your project. Step 2. Select the XY grid backdrop. New backdrop is added on the stage. Now you can see exactly how Scratch positions objects. Everything is on a grid with 2 axes. Y-axis, a vertical line that marks up and down positions. ranges from minus 180 lowest to plus 180 highest. X-axis, a horizontal line that marks left and right positions, ranges from minus 240 farthest left to plus 240 farthest right. Scratchy's default position is at the point where the x-axis and y-axis meet. Its coordinates are x0, y0. Now we can program the movements for Scratchy the cat. But first, try dragging him to the top of the stage as shown in the next figure. Position of the sprite. Now, let's make Scratchy move in a pentagon shape on the stage. This can be done by changing the x and y coordinate of Scratchy. Add the following scripts and make Scratchy jump on all the corners of the pentagon. To make Scratchy move in a loop continuously, 1. Drag out the Forever command block from the control palette and place it at top of the code. See the pic given on next page. 2. Add When Flag Clicked block from Event category at the top of Forever block. 3. Click the block to execute the program. Four. Click again to stop Scratchy from moving around. This is the way to test any program, that is, just click the scripts with your mouse. Now, let's make Scratchy glide around with jumping from point to point. See the pic given below. To do this, 1. Click the motion palette, drag out 5 glide commands and join them together. 2. Copy the coordinates from the Go To blocks. Once you've finished with coding, click on the sprite to see the results. Now, from the Events palette, drag out the When Clicked command and put it at the top of your script. Now, run the program by clicking on the green flag. In Scratch 3.x, the pen palette is available in the Add extension. Let us add the pen blocks and drag out the 4 green pen blocks so that when Scratchy moves, it'll draw a magic star web. Step 1. Click on the Add extension button. Step 2. Click on pen. Step 3. Add different pen code blocks in the script as shown in the figure. Occasionally, when you run your program, there is an error. It is a software bug. This is the most exciting part of computer programming. Discovering an error in something you have made and then solving the problem. In this case, sometimes Scratchy will draw an odd line at the beginning of the program. If we drag Scratchy anywhere else on the stage and then press green flag, he draws an extra line because he starts in the wrong place. Try doing this multiple times to see if you can spot the bug. This software bug can be fixed by adding some more code. In this case, simply place a new Go To block from the blue motion palette above the green pen blocks and below the When Clicked block. With this little correction, Scratchy will always begin drawing from the correct position in the grid. The bug is gone. Saving the project. Remember to save this project so that you can play with it later. Step 1. Click File menu. Step 2. Select Save to your computer. Step 3. Type the name of the project. Step 4. Click Save.